Hello, and welcome back to Bagger Breaks It Down. In this episode, we're looking at composite functions, and we're going to focus on writing composite functions. So basically, we're going to take two functions and create a new function, just like these little guys are illustrating. So let's check it out. So first off, a little reminder on what a composition of function is. It's two functions connected by the fact the output of one is the input of the other. So this function on the inside, we plug it into that function on the outside. On the previous episode, we simply evaluated. Here we're writing new functions. So below, we have an illustration of how this whole process is done. So we want to find f of g of x. So notice here, the first thing they did is they substituted the function notation in. So they're saying f of g of x. So notice, like, here's the function f of x. It's x squared plus 3. And the first thing they did is they rewrote it using the function notation g of x. And then in this step, they substituted that g of x is x minus 2. That's what they substituted in. Okay. Honestly, we can just totally start here in these problems. Make that substitution. Inside function goes into the outside function. And then the rest is just a matter of simplifying the results. So in problem number 10 here, my two functions are f of x equals 4x squared minus 2 and g of x equals negative 3x plus 1. Find a formula for g of f of x. So I want to plug f of x into the function g of x. So notice g of x has a single variable right here. I need to replace that with the function f. Okay, so we know that g of x is equal to negative 3x plus 1. So what I'm going to do is I'm going to plug f of x in. So this is going in here. Now I can do that using that function notation that was illustrated on the previous slide. So I'll do that. So 3 times f of x plus 1. Okay. And then I really want to put f of x, which is 4x squared minus 2, in its place. So now I have negative 3 times the function f of x, so 4x squared minus 2, and then plus 1. So I'm making the substitution. Inside function goes into the outside function, okay? And what is left here for me to do is to simplify this, okay? To simplify this, I want to distribute the negative 3. So negative 3 times 4x squared is negative 12x squared. Negative 3 times negative 2 is positive 6. And then I still have that plus 1. And then combine like terms. So I have negative 12x squared plus 7. And this is my function, g of f of x. That's my answer. Okay. So whatever's on the inside, substitute that into the outside function. That's what we did. So f of x, we substituted that into g of x, okay? On the right side, we have a really simple problem. Evaluate, okay? Evaluates, yes, they are simple. I don't have to do all this work, okay? I can just start on the inside, evaluate g of 9, okay? So plug that in. So I have, what, negative 3 times 9 plus 1, and that's negative 26. All right, and so the problem then becomes f of negative 26, and then I want to evaluate that. So that is 4 times negative 26 squared minus 2. Probably want to use a calculator for that, right? I don't have a calculator on me, but check that out and like calculate it out and get your answer. Sorry about that. Okay. So number 11 involves rational functions, okay? And we're still doing the composition. We're taking whatever's on the inside, plugging it into whatever's on the outside. So this is f of g of x. So into the function of f, I want to plug in the function g of x. All right. F is 2 over x minus 1, okay? So I have 2 over x minus 1. So the x I'm going to replace with g of x. Okay. So now, after my function notation, I'm actually going to substitute in g of x. G of x is 3 over x, okay? So we have 2 over, and then g of x is the function 3 over x minus 1, okay? So this is where we are currently, 2 over 3 over x minus 1. Now this is a complex fraction, and as you know from Algebra 2, we're not allowed to leave, that's not proper. So the issue is the 3 divided by x. So specifically that division by x is a problem. So I am going to get rid of the division by x by multiplying all 3 terms by x. Okay, because I got to keep things fair. So that means like on top, I have 2x. On the bottom, x times 3 over x is just 3, and then minus 1 times x, okay? And that's my answer. So we're making the substitution. The inside function goes into the outside function. Substitute the rule in, simplify the results, okay? So on the right side, we have g of f of x, which you might be thinking, like, isn't that what we just did? No, we did f of g of x. So are they going to be the same? What do you think? Well, let's check it out. Okay. So into the function of g, I'm going to plug in the function f of x. So what will that look like? Okay. Well, g is 3 over x. So I'm going to go 3 over, but remember, replace x with the function f of x. So let's actually make the substitution of the rule. So now I have 3 over f of x. Well, f of x is the function 2 over x minus 1. So once again, this is a complex fraction. I'm not allowed to leave it like this. Who's causing all the problems here? That's right. The x minus 1 is causing all the problems. So I'm going to multiply both terms by x minus 1, because that's how I'll get rid of it. So on top, I have 3 times x minus 3. And on the bottom, because these canceled, I just have 2. And so 3x minus 3 divided by 2 is my answer here. So we can write composite functions by substituting a function into another function, okay? So whatever function is on the inside, that's going to get put into the outside function. So if you look at the example here, they've substituted g of x into f of x. So make the substitution, simplify. And that's how Becker breaks it down.